So day 2 of our complex numbers. So we're going to talk about complex conjugates. Complex conjugates are complex numbers with equivalent real parts of opposite imaginary parts. Their product is a real number. So what you need to know is we have difference of what? Squares. Showed you this yesterday, didn't I?
Yeah.
Now, what's funny about this is I typically get people remember the word conjugate and they remember complex conjugate. And if I have 4, that's not a 4, but okay, 7 minus x, and I have 7 plus x, those are conjugates of each other. Because when I multiply them together, am I going to have that middle term? No. They are conjugates of each other. But they're not complex conjugates because they don't have a what? What makes it a complex number? A real part and a imaginary part. So 7 plus I and 7 minus x and 7 plus x are just conjugates. Okay? So if you want to remember one word, just remember conjugate. It doesn't have to be, you don't have to remember complex conjugate, because if you tell me complex conjugate here, you're wrong. But if you would just say conjugate, would you be okay? Yes. Okay, so what happens when we have a conjugate, and the whole point of it is when I multiply it out, right underneath it, it shows you it'd be a squared minus abi plus abi minus b squared I squared. So these would zero out, and I squared is negative 1, so I get a squared plus b squared, which is not the difference of squares, it is now the sum of squares. And it will be a real number. As long as there's not an x in there, it will be a number. 6, 15, 13. It will be a number. Okay, we cannot leave negative exponents in a denominator. We cannot leave radicals in a denominator. And we cannot leave imaginary numbers in denominators. So we have to use conjugates to get them out. So that is what you're doing today. You're using complex conjugates or conjugates to remove the imaginary number from the denominator. So first of all, we're going to talk about the example. I have 7 minus 8i, 7 plus 8i. Negative 2 plus I, negative 2 minus I. The sign of the first one has to remain the same. It's the second term that has the positive and negative. If you change the positive and negative on the first term, it is not going to multiply. Conjugates always come in pairs. So if I told you 6 minus 5i was one factor, what has to be the other factor? 6 plus 5i. These always come in conjugate pairs. They never come by themselves when we're solving, like we're having solutions. And that's where we're going to get to eventually. Not today, but we will get there eventually. Is everybody good on the slide?
Mm-hmm. Wait, are we going to do one of them?
Yes. That's why I asked if everybody was good on the slide.
Yes.
Melanie, you good? Okay. So, what you're doing today is you're going to simplify a quotient with complex numbers. Write your answer in standard form. So what is standard form again? A plus BI. Real part, imaginary part. Yes?
Yeah.
Okay, so I have 10 over 2 minus I. I cannot have an imaginary number in the denominator. So I need to multiply by the denominator's conjugate. And if I multiply the bottom, I have to multiply the top, or the denominator and the numerator. Let's use big kid words, right? So what is the conjugate of 2 minus I? So 2 plus I. And 2 plus I. So why do you think you did yesterday before today?
So we understood.
You understood it. So I like to do the denominator because it's going to come out to be my whole number, because I just told you that, didn't I? Okay. So if I do that, we know when we have conjugates, the middle term zeroes out. Correct? Every time. So you square the first. So 2 squared is 4. And then you multiply the other two. So negative I squared. What's negative I squared?
-1.
Negative 1. So I have a negative 1.
So 4.
No,
It would be 5.
it would be 5
4 plus 1.
because you have 4 plus 1. So my denominator is going to be 5. Okay, so now I need to do my numerator, so I just need to what?
Distribute.
Distribute. So I have 20 plus 10i. Now, I have now 20 plus 10i over 5. Well, does that have a real part and an imaginary part? No.
Oh, no.
It's all smushed together, yes? So if I can add fractions with common denominators and get one fraction, can I pull them apart? Yes. So this would be 20 over 5 plus 10 over 5i. I has to be out to the side. Can I leave it like that?
Simplify. Yeah.
You have to simplify. So I get 4 plus 2i. Okay, is that in standard form? Yes. So that's what you're doing.
That's it.
Well,
Yeah.
for now.
Okay. Well,
For now.
that's terrifying.
Okay, so the next one I have is 80 over 2 minus 6i.
2 plus 6.
So I have an imaginary number in the denominator, which I cannot have. So I have to multiply by its conjugate. So 2 plus 6i. Okay, so you keep going. Did you get 4 plus 12i?
Yeah.
Guys, what do you notice at the beginning?
You can factor.
Couldn't you factor out a 2? So could I have made this... Second, my screen jumped. Could I have made it 40 over 1 minus 3i?
Yeah.
Yes, I could have. But the main thing is you need to make sure that 2 divided by 2 is 1, not nothing. Because a lot of times you guys do that and leave it as nothing, don't you? So if you see that everything has a 2, could you make your number smaller at the beginning? Yes. If I made them smaller at the beginning, would I have to reduce at the end?
Yeah.
No. You shouldn't. Because you're reducing before you started.
Yeah.
Okay? So, did you find your error?
No, I was right. I just
Okay.
didn't know why you split it, but you just do.
Yep, you have to. You have to have real and imaginary. Okay, so now we have the next one. What's different about it? Anything?
2 on the top.
Okay, so there's two terms on the top, right? So we need to remember it's one whole thing, yes? So putting parentheses around it might help you do that. And am I going to do it any differently?
No.
So go for it.
Wait.
The green doesn't show very well. Okay, did you get negative 2 minus I?
Yeah.
No, no.
Where'd you get the 10?
Okay,
The negative?
yeah, where did the
Okay,
10 come
because it was plus 6I squared. So it's plus 6I squared. So it made it negative 6, and negative 4 is negative 10.
Oh, no, I was.
Okay, now, guys, I have a question for you. Do you think they're all going to end up nice numbers? No, they're not. Are you going to have fractions? Yeah, can you have fractions on the real part but not the imaginary part?
Yeah.
Yeah, could you have different denominators on both?
Yeah.
Yeah, if they simplified down. Okay, they're not always going to be nice whole numbers. I don't know why they gave you 3 examples with nice whole numbers, because they're not always going to be that way. But are you always going to get a whole number in the denominator if you do the right conjugate? Yes. Okay. Questions on this? Did anybody who did not have negative 2 minus I find their mistake?
Yeah.
Caden, did you find
I
yours?
just don't know what I'm doing yet.
Okay. Okay, now we need to factor. So I came back here, right here. We're going to look right at this real quick. Right here, yes? And are these factors?
Yeah.
Yeah? So we know if I have 4 minus x squared, that factors to 2 minus x and to what? Plus x, because those are the difference of squares, yes? Okay, but if I have the sum of squares, what's this going to factor to? Plus or minus, but what's going to be back there? An I. Because what is I squared?
Negative 1.
Negative 1. And you're going to have that negative number times negative 1, so it's going to make it a positive. So you're going to get those conjugate pairs, but with imaginary. So if we factor the sum of squares pattern is going to be, actually, let's write it out. So if I have a squared plus b squared, it's going to factor to a minus bi and a what? Plus bi. Because when I multiply this, I will get negative b squared I squared, which is going to make it a positive b, not a negative. Right? Okay, so I have 7x, not 7, x squared plus y squared. Do I have squares? Are they sums? Yes. So x plus minus, and then what do I have to do with my y? Make it a yi and a yi. Because I squared is going to make that a positive with the negative, correct? Okay. So now I have 12x squared plus 3. I need to factor it.
Can you take
3.
a 3 out?
I definitely can take a 3 out, right?
Yeah.
So then I have 4x squared plus 1. So now can I factor that? So it'd be 2x and 2x, right? And then it'd be plus and minus. Just an I and an I. Because 1 is 1, right?
Yeah.
Okay. Try the next one on your own. 4x squared plus 25. Bless you. Did you get 2x plus 5i and 2x minus 5i?
I didn't, but that's just because I wasn't done.
Oh, okay. So 8y squared plus 18. Take out a 2. And then can you factor it? Jacob, what do you get? So do it right now.
30 years later. No, what I'm saying.
You could just tell me while you're writing it down.
Alright, so we're gonna factor out a 2.
Uh-huh.
And it's gonna be 4y plus 9.
Okay.
And 4y minus 9.
No.
What did I do?
So you factor out a 2 and you get 4y squared plus 9. So now have to take the square root.
Oh.
So 2y plus 2y minus, and then it's 3 what? I and 3i. You gotta have the I there, right? Because without the I, you're gonna get the difference of squares, and we want the what? Sum.
Because you've been.
I forgot to factor it again.
Okay,
Oh my god, I got this dog trying it down. The next thing you know, you get.
so now we're gonna use it to solve. Okay, we can do two things. I have x squared plus 4 equals 0, yes? Okay, so I could factor it and set those equal to 0. Or there's no middle term, right? So can't I just subtract 4?
Yeah.
Okay. So
X squared
x squared equals negative 4, and then take the what on both sides? Square root. So x equals, nope, nope, plus and minus,
Gonna defeat that.
nope,
What's it?
2i. Why is it 2i, guys? Because it's a negative 4. Okay, so this is the thing. First of all, you guys forgot the plus or minus, correct? Yeah, that's going to get you in trouble. Okay, so let's try the factoring method. So if I have x squared plus 49, do I have sum of squares?
Yeah.
Yes. So we just went through this. So I have to put x minus 7 what? I and x plus 7i. And then I set both of these equal to 0, yes? And does this show me right there that I'm going to get plus or minus 7i?
Yes.
So if you factor, chances are you won't forget the plus or minus, correct?
So can we even do that? Can we do what you did for B and not? do
Yeah,
the square
I'm
root?
saying you could use either way.
Okay.
You can't forget the plus or minus. Whatever way you use, I want you to use it so you get the correct answer. So you get to do the next one.
Or C? Do you C together?
Yeah. This one you might get stuck.
Which one?
See?
I don't know.
So we're solving, so it has to be set equal to what?
0.
Jacob wants to factor out of 5.
And that's the square.
Well, they're not, that's fine. You can do that. They're not perfect squares, so can you factor it? Can you use the method on B?
Yeah. No.
No, you have to use the method on what? A.
Darn.
So it's set them equal to what? 0. Does 0 equal 5? No. So what do I do with x squared plus 5 equals 0? Subtract the 5. And then? Take the square root. So you have to remember what and what? Plus or minus.
5 square root.
Yeah, square root,
Nope, not square root of negative 5.
negative 5, just negative 5.
Nope.
Or just 5i.
Square root
Square root.
of 5i.
I.
You can't leave the negative in there. You can't leave the negative in there because that negative gives you that I, correct?
So is that the only way you can solve that one?
Actually, you can factor it. Right here, if you know, like, if you've done it long enough, what's the square root? Like here, we took the square root of 49, yes? Well, what's the square root of 5? The square root of 5?
5.
The square root of 5? Yeah? So I could just say x minus the square root of 5, I, and x what? Plus the square root of 5i. That comes from doing this a lot. Okay? So you can do it, but I don't, that comes from me doing this a lot.
Where did you get the negative 5? Like, was it the one that was on the outside or the one that was...
Well, you subtract the 5 over, so you get negative 5.
Okay, so the outside 5 doesn't do anything.
Well, because it's 0 equals 5, there's no variable. So
Okay.
0 can't equal 5 without a variable.
Okay.
If there was a variable there, if it was like 5x, then it would be 0. Okay, other questions? That's it. So your assignment today is the rest of the worksheet.